Okay, hey guys, here we're going to tackle absolute value inequalities a little bit more. Got a couple more examples for you. The first one is going to be very similar to the ones we did in class. It's going to say 2 times the absolute value of x plus 4 minus 3 is less than negative 2. Okay, so as we do this, we got to think of that variable as an onion, and we're going to peel off the layers, right? So our furthest out layer is this minus 3 over here. As we undo that, we add 3 to both sides. We get left with 2 times the absolute value of x plus 4 is less than 1. Excellent. Now the next layer is going to be dealing with this 2. We have to keep our absolute value sign still because the 2 is outside. So we want to undo our multiplication. We divide by 2 on both sides. When we do that, we bring down our absolute value of x plus 4 is less than, well, 1 divided by 2 is just 1/2. You don't have to do any math. You can just leave it like that. Or you could say 0.5. However, I would prefer that you just leave it as the fraction, okay? Now we're at a point when we have nothing outside that absolute value sign. Now we're at a point where we can undo the absolute value. Remember, undoing the absolute value is what makes us do something to the other side. So the first thing you do is you write it as you see it. X plus 4 is less than 1/2. Or x plus 4, and this time we've got to switch the direction of our sign. Greater than, and we have to change the sign of our answer here, negative 1/2. So that's how you get it split into those two equations when you undo your absolute value. So now, subtract 4 from both sides, and you're going to get x is less than, so 1/2 minus 4 is going to give you a negative 3.5. So x is less than negative 3.5. Now on this other equation, you're going to subtract 4 from both sides, and you're going to get that x is greater than negative 4.5. Okay, well now let's graph it. So the 2 points we've got to make sure are on our number line. Negative 4.5 and negative 3.5. Remember how those negatives work as you write this out. Because it is only less than or greater than, no equal to, they're going to be open circles on both of them. Let's start with our x is less than negative 3.5. Less than negative 3.5 goes to our left. Then look at x is greater than negative 4.5. That graph's going to go to the right, and look at, they're going to connect, and that would be your graph for that one. If you've really looked closely at the examples we did in class and so far on this video, we've dealt with absolute values being less than something on the other side. Our next examples are going to twist it, and our absolute value is going to be greater than the other side. So for example, let's look at 4 plus the absolute value of x being greater than 5. Okay? Doesn't change the process of how we solve it. You are going to see a little difference when we go to graph it, and I want you to be watching for that difference. So our first step here is going to be to peel off this 4, and we're going to move that by subtracting 4 from both sides. When we do that, we have our absolute value of x, don't get rid of those absolute value signs yet, is greater than 1. Okay, now we have to undo our absolute value sign. This is where we get those 2 inequalities from this one. So here it's going to be exactly like you see it. X is greater than 1, or x is change the sign, less than, change the sign again, -1. Okay, so you've got to turn that inequality sign as well as change the side of what it's unequal to. So now, since x is by itself, we're ready to graph. The 2 points we've got to make sure are on our line are a -1, you might want to put 0, and a +1. Because it's just greater than, less than, it's going to be open circles on both sides. Now let's tackle each inequality. X is greater than 1. Well, if we look over here at the 1, greater than is going to be off to the right. Now you've got x is less than -1. That's going to be off to the left. If you notice, this is different than the other graphs we've been seeing so far. That's okay. It's because it started off as a greater than problem rather than a less than problem. Your key here is don't worry about memorizing it. Just work the problem and let the problem show itself to you. Let's go ahead and try one more. Let's go 2 times the absolute value of x plus 2 is greater than 6. Okay, let's start by peeling off those layers. The first thing is whatever is outside the absolute value sign. So that's going to be this 2 right here. We want to divide by 2 because what that's saying is 2 times the absolute value. So we're going to divide both sides by 2. That means we bring down our absolute value of x plus 2 is greater than 3. At this point, since there's nothing outside that absolute value, this is where we get our 2 inequalities from. The first one gets written down exactly as you see it. X plus 2 is greater than 3. Or the other one, x plus 2, turn your sign around, is less than, put the opposite sign for the 3, -3. Oops, answer the phone. To solve these then, we're going to have to subtract 2 from both sides. You would get x is greater than 3. And if we subtract 2 from both sides here, we would get x is less than -5. This is completely okay. I messed that one up. Hold on. 3 minus 2 is actually a 1. So if all of you were screaming at me, no, you were right. I'm sorry. End of a long day. Here we go. X is greater than 1 because 3 minus 2 is 1. And x is less than -5. Okay, let's graph it. So, points we need to have on here, definitely a -5. You might want a 0 and a 1 on there, good. Because there's no equals sign, these are open on the -5 and the 1. Start here with your x is greater than 1. So greater than is off to the right. X is less than -5. Less than is going to the left. And that would be how our graph would look, and that would be completely correct. So if you have any other questions, definitely come in and see me at lunch or after school. Other than that, I hope you have a great day. I'll see you on Wednesday.